So I'm going to do some more examples of graphing with tangent and cotangent. So this is really an extension of my lesson video, where in my lesson videos I break down like all the steps in total detail. And then the point of this video is just to kind of add on to that and show more examples in case you wanted more. So these are the 3 examples I'm going to go through. You can pause the video or fast forward to whatever you want to see. All right, so let's just jump into it. And I haven't prepared anything in advance, so I just want you to kind of see how I really think through this. A lot of times when I make videos, I'll prepare things in advance, but I'm just going to show you my thought process. Okay, so we're going to start with tangent of 3x plus pi over 4. Okay, so the first thing that I always want to do with these functions is I want to figure out what is the period. And so the period can be found by taking pi over b. Now, in this case, my b is this 3, so this will be pi over 3. So that's going to be my period. And so then I always like to also figure out what steps should I be taking in my table. So I like to divide this by 4. So this will become pi over 3 times 1 over 4. So this becomes pi over 12. Okay, so that's the first thing. And then the other thing is the asymptotes, because that really tells me where I need to start and end. And then just as a reminder, so what's key with finding asymptotes, so it depends on if you have tangent or cotangent. In this case, we have tangent function, so I'm going to take bx equals negative pi over 2 and bx equals pi over 2. So I'm literally just going to take this inside part here, all of the 3x and plus pi over 4. So let's set this up. 3x plus pi over 4 equals negative pi over 2, and 3x plus pi over 4 equals pi over 2. Cool. So now I can go ahead and solve for both of these. So if I subtract off the negative pi, subtract off pi over 4, I get 3x equals negative 3 pi over 4 and 3x equals pi over 4. And then if I divide both sides by 3, so for this one I'll get pi over 4, and then for this other one I will get pi over 12. Okay, so you always want to start with the lowest for your table. So we're going to start at negative pi over 4, and hopefully, if we do it right, we end at pi over 12. So we will see. We will see. Okay, so let's see. I'm going to start at negative pi over 4, and then remember I want to take those pi over 12 steps. So what would probably be helpful is to remember that negative pi over 4, if I convert that to a fraction over 12, this would be negative 3 pi over 12. So if I add pi over 12 to this, this will become, so let's see, negative 3 pi over 12 plus pi over 12. That'll become negative 2 pi over 12, so that's negative pi over 6. So negative pi over 6. And then if I add another pi over 12, this will become negative pi over 12. If I add another pi over 12, that'll be 0. And then, hey, look, isn't that what we said we wanted to be the end of the interval? Pi over 12 is our last step. So I can get rid of the rest of this scratch work. So now I have all my x values. So now I can go through and start plugging stuff in and figuring out what my y values should be. So let's clear some space. Okay, and oops, I lost one of my values. Let's see, this should be negative pi over 6. Okay, so don't want anybody falling off. Okay, so now I can start plugging stuff in. So I'm going to plug in first that negative pi over 4. So this becomes negative 3 pi over 4 plus pi over 4. So that's going to give me tangent of negative pi over 2, which I know is going to be undefined because that was kind of the whole point. And then I'll take tangent of, let's see, so if I multiply 3 times negative pi over 6, this will come out to negative pi over 2 plus pi over 4. So that's going to be equal to tangent of negative pi over 4. And I know that that equals negative 1. Then if I plug in negative pi over 12 into this, this will simplify to tangent of, let's see, this will simplify to tangent of negative pi over 4 plus pi over 4. So that's tangent of 0, so that just equals 0. And then if I plug 0 into this guy, this will just come out to be 1, because tangent of pi over 4 is equal to 1. And then when I plug in tangent of pi over 12 back into this, this will give me another undefined. So I have all my y values. All right, so now I can keep going. So let's see, what intervals do I want to do this in? Why don't we do this in, how about pi over 12 x intervals? So pi over 12, pi over 6, 3 pi over 12 will become pi over 4, 4 pi over 12 will become pi over 3. So I'm just adding pi over 12 intervals, but it just so happens that these all end up becoming simplified fractions, and then I can go the other way as well. And I'm just going to label all of this so that I don't forget. And then I'm going to go from 1 to -1, and so now I can start plotting. So first things first, I have to mark my asymptotes. So there we go. And so let's see, there are my asymptotes, and then I can start plotting my points. Negative pi over 6, -1, negative pi over 12, 0, 0, 1, and then I can go ahead and connect. Boom. Okay, so there's my first points, and then if I want to continue this, so let's see, I can continue my pattern to just get my second interval. Boom. And I know that somewhere over here there would be another asymptote. I just don't have it marked on the axes, but there you go. So moving on, we've got y equals -2 plus 3 times cotangent of 4x minus pi. So once again, let's figure out what is the period here. So here, if I take b divided by, or sorry, pi divided by b, my bad, pi divided by b, that's going to be pi over 4. So then the steps that I'm going to take are going to be pi over 4 divided by 4, so that's going to be 1 over, or pi over 16. I cannot math right now. Okay, so now let's talk about asymptotes. So as we know, so you've got bx equals 0 and bx equals pi. So then I'm just going to take whatever's inside the parentheses of my cotangent function. So I have 4x minus pi equals 0. 4x minus pi equals pi. So if I go through and I solve for this, I get 4x equals pi and 4x equals 2 pi. So when I divide both sides by 4, I get x equals pi over 4 and x equals pi over 2. So remember, this is going to be where we start, and hopefully if I do my steps right, this is where I end. Okay, so I'm going to start with pi over 4, and so then remember, I take pi over 16 steps. So it might be helpful to know that pi over 4 is the same thing as 4 pi over 16. That'll just help me to calculate my steps. So if I add pi over 16 to that, I get 5 pi over 16. If I add another pi over 16 to this, I get 6 pi over 16, which if I divide the top and bottom by 2, that becomes 3 pi over 8. 3 pi over 8. So let me get rid of that scratch work. And then if I continue on, so this was, the next step is going to be 7 pi over 16, and then we get 8 pi over 16, and 8 pi over 16 works out to pi over 2. And hey, wasn't that what I wanted as my end? So I know that I've done this right. So now I can clear some space and we can start figuring out our y values. So just to double check everything, so okay, I can plug in pi over 4 and I can see that I'm going to end up with cotangent of 0, so that's going to be undefined. So I'm just doing like quick checks here. Next, I'm going to have 4 times 5 pi over 16 minus pi. So that's going to come out to 5 pi over 4 minus pi, so that's going to equal -2 plus 3 cotangent of, let's see, just pi over 4. So this, the cotangent part, this is equal to 1. So then I'm left with -2 plus 3 times 1, so that just equals 1. Okay, let me clear some space. And we'll continue on down the line. So now I've got -2 plus 3 cotangent of 4x minus pi. Oops, sorry. Times 3 pi over 8 minus pi, my bad. Okay, so now this comes out to 3 pi over 2 minus pi. So that's going to give me just pi over 2. So I know that this is equal to 0, so then ultimately I'm just left with -2. And then this next one, let's see, 4 times 7 pi over 16 minus pi. So that's going to give me 7 pi over 4 minus pi, so that comes out to 3 pi over 4. So this will equal -1. So I'm left with -2 plus 3 times -1, which will be -5. And then this last one will be the asymptote, so it's undefined, and you can check my math on that. Okay, so now I've got all my points, so we are ready to rock and roll. So I've got everything labeled here. I think I'm going to change my axes actually to look like this. And okay, so how should I set up my axes? I think I'll go in pi over 8 quantities. So 2 pi over 8 will become pi over 4, and then 3 pi over 8, pi over 2, 5 pi over 8, let's see, 6 pi over 8 will become 3 pi over 4, 7 pi over 8, and then pi. Okay, so now I can go ahead and label my asymptotes. So there we go there. And here's another one. And okay, so now I can also set up my y values. So let's make this 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And now we'll plot our points. So I've got 5 pi over 16. So that's going to be right here. And then 3 pi over 8, -2. So that's going to be down here. Hopefully you can see that. And then 7 pi over 16 and -5. That'll be here. So then I can go ahead and connect everything. And so I want to get this over a 2-period interval so I can continue this pattern now. So I've got a point here, here, and here. And if I wanted to continue this, I could also put, let's see, another asymptote here, and I could just continue the pattern this way as well. So whichever way you want to go with this is fine. Okay, so I think that gives you the idea, and so on and so forth. So there you go. So there's the graph for that one. Okay, and so for my last example, so I have y equals 1 minus tangent of 2 pi x minus pi. So first things first, we've got to figure out our periods. I'd take pi divided by 2 pi, so that comes out to 1/2. So my steps in this case are going to be 1/2 divided by 4, so I'm going to take 1/8 size steps. And then this is tangent, so I can take 2 pi x minus pi, and I set that equal to -pi over 2, and then 2 pi x minus pi over 2. So you know me, I always think that you should do these on your own. So if you are watching this to try to understand this better, we've kind of got this set up. I would see if you can finish the problem from here and then hit play. So I will keep working through with this. So this will become pi over 2, and this becomes 3 pi over 2. So then ultimately I will get that x equals 1 over 4 and x equals 3 over 4. Okay, so this is going to be where I start. This is going to be where I hopefully end. And remember, I want to take those steps in 1/8. So I start here at 1/4. Remember, I take 1/8 steps, and probably helpful to remember that 1/4 is equal to 2/8. So if I continue this, I get 3/8, and then I get 4/8, which is 1/2, and then I get 5/8, and then I get 6/8, and 6/8 is 3/4, and that was what we wanted as our endpoint, right? So, okay, now I can start figuring out my y values. So let's clear some space. So plugging in my first point, so this is 1 minus tangent of 2 pi times 1/4 minus pi. So that comes out to 1 minus tangent of pi over 2 minus pi. So that equals negative pi over 2. So as we know, this will be undefined. So the whole thing ends up being undefined. Now I'm going to have 1 minus tangent of 2 pi times 3/8 minus pi. So that's going to work out to 1 minus tangent of 3 pi over, let's see, 3 pi over 4 minus pi. So this will work out to be negative pi over 4. And so this will end up equaling -1. So then I'm left with 1 minus -1. So that's 1 plus 1, of course, that equals 2. Okay, so let me clear some space. So if I plug in 1/2, so if I plug 1/2 into this, so the 2's will drop out, so I'm just left with pi minus pi, and I know that tangent of 0 will just give me 0, so this just equals 1. And then 1 minus tangent of, let's see, 2 pi times 5/8 minus pi, so this is 1 minus tangent of 5 pi over 4 minus pi, so that gives me just pi over 4, which I know equals 1. So this will ultimately equal, this is 1. So 1 minus 1 equals 0, of course. And then the last one's going to be undefined because that was supposed to be my other asymptote. Okay, so now we're ready to rock and roll. So I'm going to set up my axes. So I'll do this in 1/4. And I'll go both directions this time. Like this. And then let's see, I need 1, 2, 1, 2. Okay, so my graph is all set up. And so first I'm going to graph my asymptotes. So I've got one here. I've got one here. If I wanted to continue the pattern, I know I'd have one here. So I'll just go ahead and continue that now. And now I'll graph my points. So I've got 3/8. So let's see. 3/8 is going to be here. I've got 1/2, 1. And then I've got 5/8, 0. And I can connect those like so, and then I can continue the pattern. So here, here, and here. Now I've got my 2-period interval, or if you wanted to graph the other side, you'd have here, here, and here. I didn't quite get my spacing quite right. Here, here, and then somewhere over here. Okay, and so that is our last example. So that's it for this one. If you found this helpful, consider leaving a like or a comment. And otherwise, thanks for watching, guys. I'll catch you in the next video.